Thank you. So imagine, guys, that you're in front of an augmented reality engine that transforms your ideas into a physical product. A physical product that, in fact, low carbon and helps our society to rebuild. Let me introduce you to direct digital manufacturing and where we are today. Digital manufacturing is a manufacturing system which is very simple. You start with some data designed by engineers, by product designers, and you transform it in one batch into a physical product by using 3D printing technology. So in fact, you grow the part layer by layer in batches with several parts, and when the system is finished, you take them out, you scan them, you optically compare the physical data to the digital data, you clean room pack it, and you send it to a customer. Typical products we make are in the petrochemical industry, different other industries. We are in art, we are in science. We make jewels, we make medical implants based on CT and MRI scans, and we make nice birds, like this one for the Queen of Bhutan. All this kind of personalized manufacturing started from an analog side, and we know what happened in the analog world. In the past 100 years, manufacturing has been always predominantly in the market. So we used our natural resources, we transformed them, and in fact, we made products that ended on a landfill. In the digital world, it's different. We use data, communication, in fact, to transform data into physical parts, preferably into a cradle-to-cradle philosophy. So we try to reuse as much the material that we have each time after the life cycle has passed. So if you see a normal supply chain for an analog process, it's quite complex. So you start by taking some feedstock in the Middle East, in Africa, and you transform this into parts. The parts you send over to a company that assembles them, finally into a big assembly like a car. So each of these steps generates some toxicity. It needs some consumables. And at the end, we are moving stocks instead of producing parts. So parts that are made today are traveling more kilometers than they are in a factory. And this changes the way that we look and that we have to look into manufacturing. If you see now how a digital process is run, we use near-shore technologies. So it means that we have a digital plant, and around the digital plant, we have a perimeter of, let's say, about 150 kilometers. This plant, we connect and we interface with people that are designing in different industries, and we try to help them to stay within the same material. They design, send over to Malot, and Malot transforms. This is a digital process. If you see a typical chain, it starts by taking a CT scan or an MRI. This is transformed into a topography that is sent to a dental lab. The dental lab designs a prosthesis. The prosthesis is grown by additive manufacturing. We finish it. We send it back to the dental lab. The dental lab finishes it, and it goes to the patient, all within 48 hours. Enjoy. When the part's finished, we clean room pack it. It's very important in the medical industry. All done by local people. So we asked the guys from Future-Proofed, Serge de Geldere, to run an analysis on the impact of our technology. And you see today that by using the same transport modus, so the same number of lorries on the road, we can in fact supply 18 times more customers using the same infrastructure. We use 5 times less consumables to make the same product. We use renewable resources to fire the machines. And at the end, the product is made into a cradle-to-cradle philosophy. So if you know that Europe asks us to be, in 2050, running factories with a factor 10 reduction on carbon and on impact, environmental impact, then we may conclude, and future-proofed help us, that we are today on factor 8. So this means as well that if we further develop into a business, that we will help people to reduce their impact by creating things in the local environment with local people within the culture of the city. So what we are doing now, we are setting up, based on this philosophy, we are setting up different manufacturing systems around the world. And these will be connected with semantic web technology. So web technology that understands what kind of product is loaded onto the system. This will help people to develop in their own ecosystem without jeopardizing another one. So people all around the world can design and send to a manufacturing center without having big physical transport in the system. And this is what we as a company and I as an entrepreneur offer to you, the generation for change. Those who will change the world that we have changed in the past 100 years in something that is very sustainable. And we hope that after having done this, we will have a lot of leftovers for the next generation, my children and your children. Thank you.